So let's read this word problem. So two hikers set out in different directions from a marked tree on the Bruce Trail. The angle formed between their paths measures 50 degrees. After 2 hours, one hiker is 6 kilometers from the starting point and the other is 9 kilometers from the starting point. How far apart are the hikers to the nearest tenth of a kilometer? So idle me for a second, please. What happened? What do we have?
2 points.
2 hikers.
2 hikers.
On Bruce Trail. They got about. They're on a path.
Okay, Sabrina, come here. This is the tree that we have. This is the tree that's on Bruce. Whatever. Come close to me. Okay, we're the 2 hikers. We're going into different directions. We walked for 2 hours. She's 6.6 kilometers away. I'm 9 kilometers away from where we started. Right?
Okay.
The angle between our path, is 50.
Okay.
Can you draw a triangle now?
Yeah, sure.
The meters or what?
Kilometers.
Kilometers? Nobody finished it?
Okay.
6.9.
I want to see how your triangle's gonna look like before you can see
Line
mine.
is going up.
Mine is going up.
Because I started.
That's fine. You started from the top and you went down. I started the other way. It doesn't matter. But tell me, is that what you have at least?
Yes.
Okay. So this is where the hikers are. So this is now where the hikers are. So this is one hiker. This is the other hiker. Right? The question is, how far apart are the hikers to the nearest tenth of a kilometer? So what am I looking for?
What's on
Find
the
distance between two.
Yeah.
So I'm looking for this.
Yeah.
Okay? Now, you can call it whatever you like. A, B, C, you can go B, A, C, whatever you like. It doesn't matter which way you call it as long as you use the right formula, right? So, I have 2 sides and the angle between them. So I can use cosine law, right? I'm looking for A, small side A.
Which is the side.
Yeah. So I'm gonna use this formula. So the 2 hikers are
Look at that.
Put 60 instead of 6.
Get different answers. Wait.
after 2 hours, obviously, right? So, again, it's all about reading the question, reading it again, imagining what the question is asking you, and trying to draw a triangle for it. Okay? All what I had to do is I had to actually act it out for you in class, right?
Can we act it out for on time? No, sure.
You can if you want. Okay. I'm gonna go over the next part of the lesson, okay, which is solving word problems. Because tomorrow I would like to take up the day to answer questions, if you guys want me to do some questions on the board and stuff, so this way we are ready to write an assignment on Thursday, okay? It's gonna be an open book assignment, just because we have to rush this unit, okay? And just so you know, when we get to MAP 4C, we're gonna use exactly the same thing. We're not gonna be doing anything much more advanced than this, okay? All right, are we done copying this? Can I move on? Okay. You missed the whole lesson there. No, I'm just kidding. But it feels like you missed the whole day, doesn't it?
Not again, please.
Okay.
I forced myself to come today.
Thank
Oh,
you.
me too.
Thanks for coming.
Me too. Trust me, I am not feeling well. Okay. So, how do you solve word problems? Right? It would work for any word problem, but this is specifically for trigonometry. First is you're going to state the given information. Okay? State what is given to you and what basically. Let me just write exactly what I need. And then the important part is you need to draw a picture that will that is actually what the question is asking. Okay? Now, after you read the question, write the given information, draw a picture, you're going to have to choose the appropriate law, okay, or the appropriate form. What do I use for right triangles? For right triangles. SOHCAHTOA or Pythagorean theorem.
That's the one we have to
Yeah.
remember.
Right? These are the two that you can use for right triangles. These are the ones that you cannot use for oblique triangles. So use the primary trig ratios. Okay? In other words, SOHCAHTOA. And Pythagorean theorem. So in a non-right angle triangle, or what we call an oblique triangle, there's two laws. What are they? Cosine law and sine. When can I use the cosine law?
Then we have to find the side.
No.
What must that be given?
One angle.
Which angle?
The angle between.
The angle between, the contained angle, right? It has to be like that. Has to be the two sides with a contained angle, okay? And or
Three sides.
all three sides. So basically, this is what it says right here. So use a law, okay, can be used when two sides and a contained angle are given, or three sides are given. I'm gonna skip to this because it's easier to understand, it's easier to know. There's way too many different versions of this, but we're gonna write one. It's easier to determine if you're gonna use the cosine or the sine law. Sorry, it's easier to determine if it's cosine law. Okay? Because cosine law, you have two options. Two sides and the angle between them, or all three sides. Those are your options, nothing else. Now for the sine law, you must have an angle and its opposite side. This is a must, okay? So you must have an angle and its opposite side. They must be given to you. And then either another angle or another side, okay? Doesn't matter.